All right, welcome. In this video, we are going to talk through a few more examples of precipitation reactions and write out the molecular, the complete, and the net ionic equation. And please do watch this video right here showing what these actually look like in real life. So here is the video link. You need to be familiar with what these reactions look like. So it's important to know that aqueous solutions are transparent and that when you make these solids, they may look kind of cloudy. So please watch this at just like 6 minutes. And then, but I'm not going to try and show it in this video because it doesn't translate well to take a video of a video. So I'm going to just watch that one on your own. And then we'll just go over the equations here. So reaction 2, when you mix together this aqueous copper nitrate and aqueous sodium carbonate, you get this kind of cloudy blue mixture right here. So that's the example that that's the indication, I should say, that you have a precipitate, is that it's opaque, it's cloudy, it might look chunky, so it's no longer transparent. That means you've formed something insoluble. So let's figure out what that thing is that we formed. So we're mixing together copper nitrate, that's aqueous, and sodium carbonate. And I've got two aqueous compounds. So this looks like they're going to follow this double displacement pattern, which means my sodium and my copper are going to switch places. So my sodium is going to go with the nitrate, and the copper is going to go with the carbonate. So first I decide who goes with who. Then I'm going to look at the charges to figure out the subscripts. So sodium, if I look at my table of charges, so go back and look at that reference sheet, but ideally this is something that you will eventually memorize. That your sodium has a charge of +1, nitrate has a charge of -1. So look at that, no subscripts needed, awesome. Copper can have more than one charge. So let's look over here and see if we can find some more information. Well, we know that originally one copper is bonded to two nitrates, and I know that all of these charges have to add up to 0. Therefore, we can figure out that my copper must have a charge of +2. So my copper is +2. Carbonate is a polyatomic ion. It's got a charge of -2. That's, again, one of those ones that you want to like memorize. And notice sometimes I write the charge -1 or sometimes I write 1 negative. You could do it either way. It's fine. So no subscripts needed on this one. Awesome. My next step is to use my solubility rules to figure out who my precipitate is. So notice that this compound has nitrate and sodium. And if I look back up here at my list of solubility rules, which again, you will want to memorize these 5 solubility rules. So any compounds containing these things will be soluble. So compounds containing potassium and nitrate, they're always going to be soluble. In this case, sodium and nitrate. So if it's soluble, I'm going to put an AQ by it because it's going to be aqueous. Copper carbonate, if I look up here, copper and carbonate are not on my list of soluble things. So if it's not on this list, I'm going to assume that it's insoluble. So copper carbonate is insoluble. It's going to form a solid. And then I'm going to go through and balance. So let me erase this so it looks neater. I'm going to balance it. Notice I have 2 nitrates over here and only 1 over here. So I'm going to put a 2. And then I'm all balanced. Cool. Okay, the complete ionic equation. So here we are going to more accurately represent these compounds as they exist in solution. And substances which are electrolytes are going to split into ions. And the 2 examples of electrolytes are aqueous ionic compounds. So when an ionic compound dissolves in water, it's going to split in ions. And then also strong acids. And on your reference sheet, there's a list of what the acids are. So they're like things like HCl, HNO3, HBr. They all start with H. So this one, we don't have any acids, but we do have some aqueous ionic compounds. So like copper nitrate, aqueous copper nitrate, actually exists as 1 copper ion and 2 nitrate ions. Sodium carbonate splits apart into 2 sodium ions and 1 carbonate ion. Sodium nitrate exists as 2 sodium ions and 2 nitrate ions. And then copper carbonate is a solid, so it does not split into ions. And then to get my net ionic equation, I'm going to look for the spectator, so the things that don't actually change. So like nitrate, you see how it's exactly the same on the left and the right? Same thing with sodium. They're not actually reacting, they're just kind of hanging out and watching. So we call these ones spectator ions. And we eliminate the spectator ions to get the net ionic equation. So what we're left with is copper ion and the carbonate ion combine to make copper carbonate. And this is my actual precipitation reaction. So the net ionic equation only shows the species that are actually involved in a reaction and making some sort of change. So let's look at another one. So if we mix together silver nitrate and sodium chloride, these are both clear colorless solutions, but when you combine them, you make this kind of white, cloudy stuff. So that tells us that we have made some, white, insoluble solid. So let's figure out what it is that we made. All right, so let's start by writing out the molecular equation. So silver nitrate and sodium chloride, and they're going to combine, and it's a double displacement reaction. So the sodium is going to switch places with the silver. So now the sodium goes with the nitrate and the silver goes with the chloride. And now we're going to look at ion charges to figure out the subscript. Sodium is +1, nitrate's -1, so no subscript needed. Yay. Silver always forms a +1 ion, and chloride's -1, so no subscript needed there. Hooray, that made that easy. And it's also balanced already too. Okay, and then let's figure out who my solid is. So this compound contains a nitrate. We will see nitrates popping up often in this type of reaction. So any compound containing a nitrate is going to be soluble as per my solubility rules. So this is something that's good to print out maybe, or make flashcards, or these are things that you should know. Nitrate compounds are always soluble. So my nitrate's going to be soluble, so it's AQ, it's aqueous. My silver chloride, you'll see that chlorides are usually soluble except when bonded with silver, lead, or mercury. So this is my solid. So my complete ionic equation represents these as they exist in solution. So the things that will ionize, again, are my ionic compounds and strong acids. So aqueous ionic compounds and aqueous strong acids. So silver nitrate is an aqueous ionic compound. So it's actually going to exist as silver and nitrate ions separately when it's in solution. Same thing with my sodium chloride. Same thing with my sodium nitrate. But my silver chloride is a solid, so those ions have all stuck together. Okay, and then look for spectators. So nitrate's a spectator, sodium's a spectator. So we eliminate spectators to get your net ionic equation, which is this right here. And let's do one more. You can pause the video here if you've seen enough, but if you want to do one more with me, let's do one more. So this one, sodium phosphate, calcium chloride. It's another example where you got two, clear, transparent, colorless solutions. You mix them together, you make this white precipitate, right? So let's figure out what we made. What is that solid? So the molecular equation is sodium phosphate plus calcium chloride. These are both aqueous. All right. And it's a double displacement, so the sodium and the calcium switch places. And my calcium is going to go with the phosphate now, and the sodium goes with the chloride. Notice how I'm not carrying over the subscripts, just because it's a 3 over here on the sodium, not necessarily going to be a 3 over here. The way I figure out the subscripts is by looking at the ion charges. So calcium has a charge of +2, phosphate has a charge of -3. So look at your table with those, that list of ion charges right here. So we've got the, what we call the monoatomic ions, like calcium is +2, and then also the polyatomic ions that we should know over here. So use that reference page. And so in order to get these charges up to 0, I need 3 calciums for every 2 phosphates. That'll give me 6 positives and 6 negatives. And then sodium is +1, chloride is -1, so they don't need any subscripts there. So I'm going to go back now and erase my charges. That was just like a note to myself there. And let's figure out who's my soluble and who's my solid. So one of these contains sodium, and if we remember in our solubility rules, any compounds containing alkali metals are soluble. So any sodium compounds will be soluble. And then notice how phosphate compounds are not on this list of soluble things. So phosphate compounds tend to be insoluble. All right, so this one's got sodium in it, so this is soluble. Therefore, this phosphate-containing compound must be my solid. So again, if it's not on the list of soluble things, we're assuming it's insoluble. And then let's make sure we balance it. Okay, so we have 2 phosphates here, so let's put a 2 over here. And that gives me 2 times 3, 6 sodium, so I'm going to put a 6 over here. And I need 6 chloride, so I'm going to put a 3 over here, and now I'm all balanced. Now let's look at the complete ionic equation. So again, with the complete ionic, the things that you're going to ionize, there's only 2 things you should ionize. Aqueous ionic compounds and aqueous strong acids. Okay, so I'm going to ionize my sodium phosphate. That's going to give me 6 aqueous sodium ions and 2 phosphate ions. I've been kind of lazy leaving off states of matter here, but when they split apart into ions, that means that only happens when you're aqueous. Okay, so here I'm going to make 3 calcium ions and 6 chloride ions. This is important. It's not 3 Cl2 minus ions. That's not what happens. They separate out into 6 separate chloride ions. Okay. And then the solid does not dissociate because it's a solid. It's going to stay stuck together. But then I will have 6 sodium ions and 6 chloride ions over here. So what we should notice here is that we've got our spectators are sodium and chloride. So our net ionic equation is just going to include the ones that are left over. So I got 2 aqueous phosphate ions and 3 aqueous calcium ions combining to form solid calcium phosphate. And that's my net ionic equation.